Hello everybody and welcome back to the Industry Day, and we're going to be looking at how 3 of the latest standards published can really help you. So 2 are from the British Standards Institution, the new BS8298 Part 5 for stone cladding, which for the first time provides guidance on using stone cladding or linings on interiors, and BS7533 Part 101 is aimed at delivering sustainable landscape schemes. The third is the Stone Federation's own new code of practice for natural stone installations in bathrooms, shower enclosures and wet rooms. And all of these are very useful documents. There has been a pretty long wait for Part 5 of the BS 8298, the Code of Practice for the Design and Installation of natural stone cladding and lining, which covers the use of stone in interiors. It has generally been welcomed by the stone industry because it does facilitate the use of thinner stone. And you saw him just now. I'm very pleased to say that Peter Harrison, a very well-known name within the stone industry, is going to be back on stage in just a moment, who will be telling us about Part 5 and its role in the standard. So then, after we hear from Peter, we'll be going on to BS 7533, a standard for hard landscaping. And it's pretty appropriate that the presentation for this new Part 101 is going to be given by Stephen Burton, who is the Technical Director of Steintec, because it was Steintec's mortars more than 20 years ago that really did so much work improving the legitimacy of modular paving and changed the requirements for expansion joints. And apparently it really did transform the reputation of stone, which had once actually been seen as more of a problem for landscaping, but now it's more often than not the go-to material of first choice. And BS 7533 is considered by many in hard landscaping as their Bible, but lots of people were pleased to see it slim down a little bit, and it's now been reorganised into 3-part document that is a bit more easily understandable and easier to use. And finally, to conclude this seminar, we're going to be hearing from David Ellis, who has also been in the business a very long time, a partner in Stone Consultants and testing house Sandberg. And he's going to introduce the latest code of practice for using natural stone in bathrooms, shower enclosures and wet rooms, taking into account the latest updates. So it's really, really great to have so much experience on one stage this lunchtime. So I'm really, really pleased to introduce, first of all, Peter Harrison, consultant for the Stone Federation Great Britain. Welcome, Peter.
Good afternoon. It's taken us 2.5 years to produce this standard, and it's the last time we had a new British standard for interiors was 1994, so it's been a long time coming. And it covers the design installation of natural stone cladding and lining in internal. The scope of the standard gives recommendations for the design, installation and maintenance of internal cladding and lining of natural stone held directly to a structural background by fixings with or without adhesive, and is applicable to both commercial and residential applications. So we look, the 2 areas we have here are internal cladding, where we're fixing, we're securing stone with anchors back to a structure behind. It really mechanically supported and restrained. This would be stone of perhaps any thickness in office receptions or shopping malls or those sort of applications. But for the first time, we've addressed the question of stone with resin mesh on the back. You will know from the 2011 edition of BS 8000 section 11 that it always said when we're putting stone on floors and walls with mesh on the back, we should remove at least 75% of that mesh. Well, that the mesh and the resin, of course, that becomes much more of a problem. Health and safety risk of getting the resin mesh off the back. So we've addressed that by allowing you to fix meshed back stone, but it must be mechanically fixed. And the type of fixings will depend on the panel sizes, the thickness of stone. The standard covers everything above 12 millimeters. So we're talking not about tiling, we're talking about slabs of stone. You will know that tiles are pieces of stone 12 millimeters thick or less, and slabs are pieces of stone greater than 12 millimeters. Generally, we're talking about 20 millimeter thick, with or without resin mesh backing, and mechanically restrained to a substrate. And the type of anchors that we use will be dependent on the backing structure, the size of the panels, and the test data on the panels, and gives you an idea of the sort of fixings that we might be considering using, both from restraint and support applications. And this could be hotel receptions, it could be a private house, everything. The other area we've looked carefully at is soffits, restraint, sloping and flat soffits, which we might see in shopping malls, in office locations. So stone held only by adhesion is not included. So we've eliminated the option of just sticking any stone. We must have mechanical fixings on stone. 20 millimeters thick, it's not a problem. At 15, it requires some skill in understanding how to cut the stone and how to fix it. The standard covers the sampling of the stone for testing and production control testing, the provision necessary for cladding and lining to perform its functions satisfactorily, the materials and methods most frequently used for stonework. This standard excludes composite stone slabs such as honeycomb back stone. The reason that we have excluded that is that there are no British or European standards which control the quality of the resins or the honeycomb backing, and we can't guarantee its longevity. And so for that reason it is excluded at the moment from British standards. If industry was to get together and write a standard on it for quality control of production of composite units, then we might reconsider that. One of the areas that we've seen perhaps most concern is the stability of the backing structure, the stiffness of the backing structure. And so the standard is very clear in saying the deflection of any supporting structure or subframe should not exceed L over 500. Serviceability loading, where L is the span between the subframe and the support location. So we're looking very carefully at that stiffness from impact loading, lift shafts where we might people stumbling against it. We might have impact from people running into the stone with prams or with push chairs. So we're looking to make that a very substantial type of structure behind. And an L over 500 in fact first appeared in the tiling code BS8298-5 Part 1 in 2018. So that's a general run through of it. I don't have time to go into every detail, but I hope that's generated a few questions.
Yeah, so when installing any stone that's 20 mil thick, a lot of obviously tilers are just doing it with adhesive, but you're saying it, whatever the size on a wall, if it's 20 mil thick, it has to be mechanically fixed,
Yes.
even if it's small.
Well, clearly if it was only, if the slabs were less than 300 millimeter, 300 or less, why would you use 20 millimeters? You could use 12 millimeter tiles. The problem would disappear in that sense because you'd be complying with the tiling code. But what we've found over the last 10 years is a significant increase of failures particularly in residential applications, of 20 millimeter slabs coming away from the walls that were just mechanically fixed. For two reasons. One, the resin mesh wasn't being removed, the structure wasn't built accurately enough, or it was too flexible. Or even if they'd removed the mesh, they hadn't removed the resin that coats the back of the stone. And so you don't then get a bond between the stone and the adhesive. And even where the manufacturers of the adhesives have claimed that will stick to the mesh, you can't guarantee that the mesh will stay stuck to the back of the stone in all cases. Depends on it. We can't control that because there are no British or European standards that cover the mesh they use, the resin, the method of production.
So for now, thank you very much. So now I'd like to introduce Stephen Burton, who is the Technical Director of Steintec, who's going to talk about delivering sustainable landscape schemes. So thank you very much to Stephen.
So then, just a quick introduction to who I am. My name's Steve Burton. I'm Technical Director at Steintec, which is a UK manufacturer, despite the name, of high-performance paving mortar. I've specialised in pavement design since university, where I investigated and researched the causes of failure of modular pavements, which was a big topic back in the 90s. Many in the landscaping sector know me as a go-to for technical advice on hard landscape design, from past and patios through to city centres and bus lanes. Now, there are many things to consider in regard to sustainability in construction, and some of the things on this list here are not really anything to do with sustainability, and that's a common misconception, the confusion between low carbon construction or embedded carbon at construction itself and actual sustainability in the whole life cycle of a construction project. So we'll skip through some of these things quite quickly. Embodied carbon in materials, well, that's things like cements and concretes have a particularly high level of embodied carbon. Transport of materials, waste materials, energy consumption on site, water consumption on site, recycling of materials. That's where we're starting to look at things like sustainability. So the reuse of granite sets, for example, gives weight to the use of unbound construction. Without the use of cements and mortars, where we can then reuse those granite sets. But a fundamental consideration is longevity. There's not only a monetary cost to premature failure and early intervention or repairs, but also a significant environmental cost. Consider design life. How long must a project last? Not how long should it last, how long must it last? Premature failure has got to be one of the most significant environmental impacts of a project. There will always be a carbon impact in construction of any landscape scheme, and the things on that list show where we can try to minimise that impact. But if a project prematurely fails or requires premature intervention or repair, the carbon impact of lifting, reinstating, disposing of materials, having to recycle materials, that can double or triple the embedded carbon of a scheme. So this principle is fundamental to sustainability, and this is where I will come on to the British Standard in a moment. The other thing we need to consider is maintenance. Maintenance is often required on a project and is often overlooked in terms of its the overall project's sustainability. And when we design a project, we have to think about what maintenance might be required. Access to utilities, for example. We might need to choose unbound construction in order to be able to lift and reinstate to access utilities. Movement joints in bound construction. These require high maintenance. We have to replace the material, the mastic and so on at the surface. Also, inappropriate instatement of movement joints can lead to premature failure. Cleaning and replenishment of unbound jointing material. This often gives weight to bound construction being a lower maintenance option, but it all depends on how you go about designing it and assessing what this is going to be used for and how long it's going to need to be in service. So the last 2 points on that list are fundamental to sustainability. So now we come on to BS7533, Part 101. This is the new standard. It replaces the previous multiple parts of the standard into one condensed document, which has actually been written in a much more clear, concise, easy to follow manner, which aligns with many other modern British standards now. So we can use BS7533 to effectively make informed design choices to minimise long-term environmental impact of a project. And with the new BS7533 Part 101, it's much easier to achieve this, as it's set out in a much easier to follow list of key considerations. There are a number of these key considerations, just a couple of them. Assessment of trafficking. They've introduced new trafficking factors, such as channelization of traffic, so that you don't underestimate the overall impact of traffic for the whole design life of the project. And this is where a lot of mistakes have been made. Performance of materials, including permeability of bedding mortar, for example, to prevent capillary rise and moisture-related issues such as frost damage, picture framing, organic growth. It looks at types of construction. It's introduced new types of construction which were previously overlooked. We have two types of unbound construction. We have, dare I say it, concrete block paving on sand, which not the most popular one here today. Granite sets on a coarse aggregate, the traditional method of paving. And there are two types of bound construction now. And fundamentally, yes, we had the traditional type of bound construction where it was assumed that you would have a concrete base and that you would bond your paving to that concrete base. That's now called bound type B. We also have bound type A, where the concrete base has been removed. So within a given level of trafficking, we can remove that concrete base with no detrimental impact on the service life of that project. But we have to take all of these factors into account, and the new standard guides you through that iterative process to optimize your design. And that's only half the standard. The other half of the standard is actually annexes. Detailed annexes, things like movement joints and drainage channels, the common crushed slot drain, which often is a cause of early intervention, has been addressed, and guidance given on how to correctly install them. As you work your way through the list, the process does become iterative and you hone down to an optimum design. Hence, you will value engineer your project for its whole life cycle and its entire design life. Not just in terms of cost, but longevity, maintenance, and ultimately sustainability. I'll leave you with one key personal recommendation. When we look at historic architecture, we see features born out of necessity. We see arches, for example. We see similar in landscaping. For example, similar arches in laying patterns in order to enhance durability to resist gravity and braking forces in traffic. My advice here is use the choices presented to you in the British Standard to dictate the aesthetics, not vice versa. If you start off with a fixation on how it must look, it's very unlikely that you will have a scheme optimized for sustainability. An optimized design is a sustainable design, and that will give you a certain aesthetic to then work with and hone down. So there we go. Thank you very much.
Very much, Stephen. Thank you. So just before you go, I just wanted to ask you, listening to all of that, that's obviously a key mistake that some landscape architects make, is almost like putting it back to front. What other key mistakes do they make, in your opinion?
I see an awful lot of mistakes that I have to very politely correct. I think key mistakes, choice of stone. There are so many choices you can make when selecting natural stone. And there is so little guidance out there. In a trafficked environment or a public realm environment, this is more critical, where we've got things like slip and skid resistance. And we've got standard tests for measuring these parameters. And quite frankly, I find them almost meaningless. If you're going to choose a stone that's going to be in a public realm environment, get a good stone supplier. One that's got experience, where they can tell you where a particular stone has been used in a particular situation, and use that. That's much more valuable than the figures on a data sheet. So other things as well, allowing contractors to so-called value engineer, where you'll have a really good, well-selected stone for the parameters I've just told you about, and then the contractor will find some cheap stuff from somewhere else that looks the same. And it will not be the same. It will not behave the same, and allowing that to happen is probably the biggest mistake that I see.
And how do you prevent, price seemingly overriding everything?
That's about good specification and being prepared to stand by your specification. The designer is the value engineer. The value is taken into consideration, not just cost. It's taken into consideration performance and longevity, and making sure that it meets the criteria at the design stage. What an installer or a contractor might call value engineering is cost cutting. There is negative value in cost cutting, and a designer should really stand by the value engineering they did in the design process, and using a standard like 7533 allows the designer to stand by and justify their value engineering decisions at the design stage.
So really just be confident in your first recommendations.
Yeah, be confident, because if it comes back on you as a designer, it's your reputation on the line. So be prepared to stand up and say, I do not want this to happen. Ultimately, the client gets the decision, they've got the money, but at least be prepared to stand up and fight for it.
Stephen Butter, thank you so much, Technical Director of Steintec. Really great to have your views. So now let's hear from David Ellis, partner of Sandberg, presenting all about the Stone Federation's new code of practice for natural stone installation. Welcome.
Right, thank you. This is a completely new document drafted by the Stone Federation Technical Committee. It's probably been lacking in the industry for quite some time, and it's nice to actually have this available at long last. It's a document that's basically going to sit between existing British standards. Peter's already mentioned 8298 Part 5, which is going to be coming out hopefully by the end of this month, which is going to be becoming internal linings, and 5385, which again is being worked on at this moment, and hopefully, with any luck, will be out by the end of this year. And this document is hopefully a general guide which will knit those two documents and provide a lot of good general information to members and others about how to use stone and install stone in bathrooms and shower enclosures, etc. The use of stone internally, particularly in bathrooms, is becoming more and more prevalent, and we're seeing a lot of new materials being introduced, and the availability of those materials, and designers, interior designers, etc., are wanting to use those materials in innovative ways. And that typically means very, very large panels, and panels up to 2.3 meters high by 0.6 up to a meter wide. And to touch on the question that was asked earlier, these are very, very large panels. And if we're going to consider just fixing those with adhesion, there's obviously a professional engineering concern about fixing them and ensuring that they're mechanically fixed back. We have a duty of care to ensure that, and that's one of the reasons and one of the main driving forces behind this. And it's obviously usage of stone in bathrooms is very, very prestigious, used in a lot of luxury developments, and decorative stone is a very, very prominent thing in high-end residential works. The guide covers a lot of the selection considerations and issues. Suitability for the intended application sounds a very, very basic comment, but it's actually obviously fundamentally critical. When you're using materials that don't have a track record, or even those that do have a track record, you're using these materials in an environment which is quite specific to environments that it may not have been used in before. You're putting it into an environment where it's going to be subjected to moisture and drying, cyclical effects. You're also going to be subject to drying and temperature as well as moisture effects. So all of those have a combination effect on how that material will behave and its durability, both in terms of functions like expansion or how it will how it will perform in terms of its strength in service. Slip resistance is a key factor. This is a health and safety requirement, not just a technical requirement. So it's very, very important to consider that. A lot of decorative stone is selected on the basis of its aesthetic characteristics, but its technical performance is governed by the surface of the material. So there is a compromise, is the right word I think I'm looking for there, between aesthetics and technical performance, and that has to be driven by the slip resistance values. Again, the environment you're putting this material into, humidity, moisture, temperature, it must be resistant to staining. If you're using a material without a track record, very decorative material, it's likely that it might have impurities or metallic elements in it that might be subject to staining in that particular environment, i.e. they might rust. That might be on a microscopic scale, but when you've got a client or a contractor who's entering this material into a lot of different bathrooms on a large project, the effect of that can be quite considerable financially. And of course, how easy it is to clean. Common issues that occur: incorrect and inappropriate selection of stone, adhesives and grout, poor detailing, especially when you're looking at bathrooms where you have small alcoves, indents for soap baths, candles or whatever. Is the waterproofing actually going around those? Is that detailing being carefully considered, particularly the jointing as well? Incorrect substructure. The use of plywood. Bonding stone to plywood is an absolute no-no. We should be looking at a decoupling membrane or a backer board. Lack of or incorrect tanking system. Again, a lot of products are told as water resistant. What we're looking for is waterproof, and there's a very big difference between the two of them. Poor installation practices, including methods of fixing. Well, I think that's going back to the old dot and dab, which all of us dread. It causes an immense amount of problems, again, in an environment like a bathroom where you've got all of these environmental factors going on, and they're not just aesthetic, but also technical issues in how the material stays bonded and adhered to the surface. Linear drains are a major problem at the moment, and how they are dealt with, particularly in terms of how moisture is kept away from re-entering through the stone and the adhesive bond layer, where you have a waterproofing that's then dressed into the drain, but above it is not dressed and water can ingress into the stone floor structure. And insufficient understanding of the issues involved. Now, all of those are covered in the document in a lot more detail. Stone suitability is covered in quite extensively. This particular table helps in the aid of selecting which materials are beneficial for use in particular areas. What I would draw your attention to is the first two lines, where you've got marble, where you've got a very, very good classification of A, and then you've got limestone with a much broader classification of A to D. One of the important aspects here is actually what is the stone that you're using. And as an industry, we quite often specify materials or name materials as marbles if they take a very, very high polished finish. So if you look at some of our materials such as Nero Marquina, Noir Saint Laurent, Portoro, Botticino, they're all limestones, they're not marbles. So you need to be extremely aware of what actually you are buying in terms of a material type, and that's quite important. Same with onyx. That assumes that onyx here in this particular case is the siliceous true onyx, i.e. it's made up composed of silica, which has a Mohs hardness of 7. But in the commercial market, onyx is quite sold as a calcareous form. And by calcareous, it's formed of calcite, which is a Mohs hardness of 3. So again, you need to be very, very well aware of what the material is, its composition and characteristics. And that is covered in great depth in the Appendix B of the document. Document also covers testing quite extensively. The product should be CE marked. Now, as it so happens, 2023 is the 10-year anniversary of when CE marking became mandatory in the UK. I would stress that CE marking documentation is mandatory. It's in building regulations. So if it hasn't got CE marking, you shouldn't be using it. It's that simple. Brexit, we're obviously moving out of the European Union. It will be replaced by UKCA, UK Conformity Assessed. It is exactly the same, totally equivalent. The stone test methods, exactly the same. Stone product methods, or standards, exactly the same. The only difference is a change in logo. So you should be looking for the same documentation. The tests that are specified there actually relate to 12057 tiling and 12058 flooring. Those tests are covered in the product standards. There are suites of tests in there that you should look at, and they will be included in the Declaration of Performance and CE marking documentation. But I would highlight there are several tests in there that will not be part of that normal package of testing. Thermal shock resistance, how the material behaves in wetting and drying cycling. The environment it's going in a shower or bathroom, that's quite a critical aspect. Sensitivity to thermal cycling. That one is what I mentioned a little bit earlier, in that that looks again through wetting and drying cycling as to whether a stone has propensity to stain. And that's again an important aspect to look at. And finally, sensitivity to accidental staining. New standard. I think we've all probably seen staining tests where we do little dabs of contaminants on stone, clean it off, see if it works, whether the staining penetrates the stone, etc. 16140, I think that's the right number, is actually now a formal test method. It uses an automated scrub abrasion tester, and that utilizes moving heads with specific cloths, cleaning liquids under specific weights over standard number of movements for measuring contaminants and reviewing those through inspection at the end by 3 individual inspectors to establish whether the stone will stain, or if an impregnator or something's been put on it, whether it's actually performed its purpose or not. And contaminants within that are actually very, very applicable to what we're looking at in this document. One of the contaminants is artificial urine. So obviously got particular applications for what we're looking at. The document covers all of the design and installation considerations that you should be looking at. Weight is obviously a very, very key issue. If you're putting in very, very large book-matched decorative panels into a bathroom, the weight, particularly at 20 millimeters thickness, as Peter's mentioned, is quite considerable. So we should be looking at the shearing stresses on the adhesion. And that is one of the main reasons why all of these panels, these slabs, are recommended to be mechanically fixed. If adhesion should fail, there must be there must be residual mechanical restraint there. The type of fixing is quite important. Looking at the different types within there, how much of the adhesive bed is in place. The panels should be fully bedded as far as possible. They should certainly be edge bedded, and it should be about 90% bedded for a wet room or bathroom application, where the voids are not larger than the thickness of the stone. And that's quite important. We're talking virtually fully bedded, as far as reasonably practical, above 90%. The type of adhesive needs to be carefully considered. Does it perform when it's immersed in water? Is it compatible with the other materials that you're using in the building construction? Is it susceptible to staining? They're all important factors here. And movement, again, critical. You're in an environment where the materials will be subject to thermal and moisture movement. So you need movement accommodation in there. Silicon will typically accommodate 1 millimeter of movement. So to achieve 1 millimeter of movement, you need a silicon sealant of about 10 millimeters thick for a movement joint. That needs to be carefully considered, and that movement accommodation moved to the peripheral ends of your wall, typically 6 millimeters, to allow for that accommodation movement. I've mentioned substrates and backing structure. Again, no adhesion to plywood. It's an absolute no-no. Tanking, absolutely critical, as we'd all imagine in this type of environment. We must move away from localized tanking. What we should be looking at is complete tanking, floor to ceiling, with the correct upstands and correct bonding between and joining between the different sections of the tanking. Heating elements, again, will subject the wall or flooring structure to potential movement. It needs to be considered. Falls and drainage, again, critical, particularly in showers and shower units and wet rooms. Linear drains, I've already mentioned. Door openings, minimum 25 millimeter upstand should be there, unless, of course, disabled access is required. And, of course, the criticality of slip resistance. A very, very clear, defined health and safety requirements for the slip resistance. The types of wall construction, I think I'm going to basically leave. This would tally in with 8298, as Pete has already mentioned. It's generally tying into that and all of the fixing and build-up requirements within 8298, but it does give additional general guidance. Types of floor construction, again, there is information in this document, but it ties mainly with the Stone Federation Flooring Code. And if you don't have the Stone Federation Flooring Code, I suggest you get one very, very quickly. It's probably one of the most used and most beneficial documents in the industry. And that's due for revision shortly. Discuss the importance of tanking. You can see there the criticality of taking the tanking well above the bath. I think that's probably all I need to say there. Falls and drainage. We've talked about linear drains very, very briefly. They are the topic of interest at the moment because they're causing a lot of issues within the industry. Dressing into the actual drain, but still leaving the adhesion layer and the stone layer exposed in the linear drain causes a lot of problems at the moment, and how you deal with it. There's a lot of argument that that can be sealed off completely, but then that can cause issues if there's a failure in the jointing of the floor above. Gradients, again, quite important. You need to control and ensure the water is taken away from the surface, and the drain needs to be of sufficient capacity to cope with the volume of water. And that's the end of it, I'm afraid. Thank you. The document is available, I'm assured, from the Stone Federation stand today. So please go along and talk to them there and get a copy. I'm sure you'll find it very valuable.
Thank you very much, David. Really interesting. I just want to ask, though, just as a kind of overarching kind of takeaway, what would you say are the main points that specifiers should really consider when designing a natural stone bathroom?
Fly my own flag here, and Peter's. Talk to a stone specialist, somebody who really understands stone. We've got others in the audience here. It's absolutely critical. A lot of this information, when you're actually presented with it, when you actually see it, when you hear it from the likes of myself, a lot of it is common sense, but it's amazing how much common sense people manage to avoid. And you need to talk to somebody who is very knowledgeable in stone, and the likes of Peter and myself who've seen failures quite often through poor workmanship, etc. And so having somebody who understands those problems and also the issues with the material gives you a big advantage in making sure that whatever you're doing is done correctly.
And what do you think you would say is the kind of biggest point within the new code of practice that could actually help clean up some of the mistakes that have been made before?
Oh, crikey. Don't dot and dab is probably the biggest one. Use a full bed adhesive. Make sure that your system is fully mechanically restrained.
Okay, all right. Well, David, do take a seat, and I'd like to ask you to come back up again, and Stephen, if possible. I can pass you that. Thank you. Peter, just, as I talked to David, what would you say the overarching point that we should take away with the new BS8298 is? What would you say that should, when people leave this seminar and leave the show, and they're thinking about the change in this the standard, what would you say the most important changes?
Mechanically fix everything. Simple. Don't just rely on the adhesive, use mechanical fixings. That's the area where we see most failures.
And let me just pass over the microphone to you so everyone knows your question. Thank you.
Are you seeing the failures mostly because it's still got resin backed and mesh, or is it the adhesive that even if it's fully bedded, it's not strong?
We're seeing failures where stone has been stuck to plywood without a tanking system, where it's been dot and dabbed and it's starting to stain on the surface. We've seen it falling off where the mesh has come off the back of the stone, where the adhesive has not stuck to the plywood or the backing structure properly. We've seen a lot of problems where the main contractor has failed to build the backing structural wall accurately enough. And so instead of putting adhesive that's 9mm thick, it's 25mm thick. And so we're seeing major failures there. Failures where there hasn't been a full bed, and we're seeing algal growth and sort of mold growth around those areas where there's no adhesive, both walls and floors.
I'm sorry, I'm just going to press the point a bit more, if that's okay.
Yes.
So let's say scenario, the substrate's correct.
Yes.
The adhesive bed is correct. The right adhesive is being used. The marbles had all the mesh removed. Are you still seeing failures in that instance?
What we can't, no, we're not always seeing failures, but what we can't see is somebody taking ownership of the whole construction, the overall construction. So somebody builds the wall, somebody else specifies the adhesive, somebody supplies the stone, somebody else fixes it. When it fails, who's responsible? Who takes the can for that? The marble fixer might take the responsibility, but in fact, everything else might be wrong. Had that been mechanically fixed, that wouldn't have happened.
And you certainly see other aspects as well. I mean, you could do the construction, get all of the detailing right, but it might be something that's sort of hidden and slipped through. And a classic one we quite often see is where the back face of the stone is coated with an impregnator, and that automatically affects the adhesion bond. But very, very simple thing, looks a good idea, has a very, very critical effect.
How much is that going to add, would you say, though, this change in cost? As we've heard, prices.
The major contractors are already doing it. I think it's the smaller projects where there will be a challenge. And I think it's not only mechanically fixing, but it's getting the backing structure right as well. We see too many where people are using the wrong subframes to put the ply on, or not putting ply on, or simply trying to stick to a backer board. And then we're seeing somebody stumbles against it and it starts to move, and we see cracking in the stone. Yeah, it's really, if they're a competent marble contractor, they probably are already mechanically fixing. So if we're putting big slabs in a shower, the backing wall is trapped by the two side slabs, so we might not fix the backing because it can't go anywhere, but the side ones need to be fixed so they don't fall in. The competent contractors will be doing that, but we're seeing so many where they're not doing that, and they don't understand.
Okay, there's a question here.
Yeah. David, with respect to bathrooms, how do you educate the builder next door who stone is very popular for bathrooms, just for the resident? How do we get this message down that things need to be mechanically fixed for slabs? in bathrooms?
Of course, being a Stone Federation guide, we would hope that obviously the Stone Federation members would accommodate that and take all of the information aboard in that. And then it's really driving that through the Stone Federation members for their own use, and then obviously building that further out.
But obviously there are many independent contractors out there who aren't members of the Stone Federation who, you know, might not even know that you've got the code of practice out there.
Well, I suppose it's events like this then that's going to get that out. And there was certainly a lot of discussion about getting a CPD, I think, out on this as well, getting it out a little bit more into the marketplace, if you like.
Well, I didn't say when I was talking, David mentioned we've been told by BSI that 8298 will be published by the 1st of July. That will now start to appear in specifications. NBS specs will include that. If a contractor ignores that, then be it at their own risk. In the past, we've had no standard, so there's been nothing to say you've done it wrong. When the standard is out there on all new projects from that date, you would expect the specification from the architect or the interior designer to include that reference to those British standards, to understand what it means and to follow those.
Is there a danger that less natural stone then will be used?
Well, the same, to a certain extent, the same requirements are happening with ceramic and porcelain tiles, perhaps not fixing, but things like stiffness of backing structures. With the larger formats of porcelain and ceramic tiles, and a requirement under CDM for the designer to do a method statement, a risk assessment of how to handle them. That whole thing is becoming a much more controlled item for the whole of industry, I think.
Okay, thank you. No, there was another question here in the middle. Yeah.
Yeah, I just wanted to ask do you think there's a link between the Stone Federation's new Stone Academy and the need for this information to be disseminated out to the industry?
I didn't hear that, Peter, sorry.
Sorry, do you think there's a connection between the Stone Federation have got the new Stone Academy, and do you think this is one of the subjects that should be part of that Stone Academy so that members can be taught how to use these guides and be educated?
Yeah, I mean, I think when we're training, because I'm involved with the Worstful Company and look after the Craft and Training Committee, we're trying to encourage all of those people at the front line fixing and all of those designing to be aware of what the standards are, what the requirements are.
Let's just pause a moment for the other promo, just so they get a bit of an audience as well. So I think that's generally a yes, it should be included.
Yes, it should be included in any of the training sessions. And I think, as David said, we're looking to put together now with 8298 Part 5 coming out, a new seminar. 5385 Part 3, the flooring code, should be going out to public comment on the by the middle of July, I'm hoping. My concern is that every time we write a British standard, we work very hard to do that, it goes out to public comment. When we wrote the cladding code Part 2, 8298 Part 2, it went out to public comment. We had 150 comments come back, and we dealt with all of those. When Part 3 of Stone on Precast came out, we had maybe 20 comments we dealt with. When Part 4 came out, we'd already dealt with them in Part 2. So we covered all of those comments. This standard went out for public comment. We got no public comments at all. So either industry doesn't care, they haven't read it, they're not aware of it, and we publicise it through all of the press that it's out for public comment. People don't care. They will care when they fail to follow it and they get sued because they've done it wrong. That's going to be the driver, because up till now it's been difficult to prove that they should have mechanically fixed. Just been common sense. Although it says it in BS 8000 section 11 2011, nobody bothers to ever understand that code or read it. I don't suppose anybody's got it. I don't suppose anybody's ever known about it.
They do now. Just before we go, I do want to ask Stephen just a very quick question. Obviously, you know, the climate is warming, and the hotter the air, more water it can hold. In what way can natural stone really help with sustainable drainage solutions?
Well,
SUDS is a massive topic, and when the serious SUDS manual was put together, the hard landscaping aspect of it was put out to the concrete block industry, and there's a common misconception that permeable paving is concrete block paving, and it's really not the case. There are many different ways of using natural stone. In fact, there's many more ways of using natural stone in a SUDS environment as part of an overall SUDS scheme, which are often overlooked. Now, the traditional permeable pavement, the original permeable pavement, is cropped granite sets laid on a coarse aggregate, the spoil from the quarry, effectively. It's actually one of the most durable and sustainable methods of pavement construction, and it's a skill that we've largely lost in the UK. So the concrete blocks are only mimicking the engineering principles of that, but we now have so many different methods of designing SUDS schemes that you don't just have to use cropped granite sets either. You can use all different sizes and shapes of natural stone and different types of natural stone in SUDS. You can use bound permeable construction, or you can use unbound permeable construction. And I think, yes, again, the standard really helps you. And in fact, the 103, which will be the third instalment of the British Standard 7533, will actually concentrate on permeable paving. And I can tell you now, because I'm helping to put this together, it will detail the different methods of using natural stone in permeable paving. It will not concentrate on concrete anymore.
Okay, thank you. There's a question here.
Yeah, just one question on the new technical guide, David. Does it cover steam room installations, or is that still separate?
Sorry, Julie.
Does it
Steam
room installation?
No, it excludes steam rooms.
Okay, so that's still covered by a separate document,
No.
because there used to be a Stone Federation guide for steam room installation.
We have taken that out because we hadn't got enough information
Okay.
to be confident that the stone was going to work in a steam room.
Okay, is that something that is being reviewed?
Not at the moment.
Okay.
And there's another question over here. Thank you.
Hi there. You mentioned earlier about the very large panels being used internally, and now it's going to mechanical fixings. For external cladding for mechanical fixings, there's limitations on the spacing between them. When you've got the very large panels that you're talking about, is there a similar limitation to spacing of fixings for the internal cladding?
Yes. Generally, we're talking about 4 points of restraint per stone.
I appreciate that, but it's a 1200 mil between fixings.
Yeah, I mean that was the 1994 standard that said that. Now it talks about design, so you're actually doing a mechanical calculation to prove. My concern is that some people are looking to put full-size slabs on the wall. Now we can fix them, but does anybody think about CDM on mechanical, on the handling of them, or of that sort of, how do you get the slabs into the room? How do you get them on the wall? Have you got enough ceiling height to get the fixings in? I sometimes think there's a gap between what industry can properly supply and install competently and what designers and clients' expectations are.
It also goes to maybe impact resistance as well, those panels, if you've only got the 4 points.
Yeah,
of
I
the
mean,
strain.
we're relying in some extent to the adhesive to stop impact on the panels. They're filling the gap behind.
So it's a combination of adhesive
It's
and
a combination of the two, although we know from experience that the adhesive, if there's mesh on the back of the stone, will not provide a long-term stick to stop it falling off the wall. But what we're looking for is that it's there as a safeguard to make sure nothing does fall off. But I just think that the large panels present a problem to everybody. I think as an industry, as a stone industry, we should be trying to cajole the clients and the interior designers into using more manageable sized stones for two reasons. First of all, we cut down on wastage because people have an expectation of a size of slab and a finish that we can't always achieve, and we're throwing away half the slabs because the variations are not there. We've got handling problems to get them up floors. We've got manufacturing problems to get them square and installed.
Sorry, just a very clear.
Yes.
So the latest standard then will clarify that it's a recommendation to do both adhesive and fixing.
Yeah. Yes.
Yeah.
Yeah. I mean, 20mm thick material, you would use adhesive and mechanical fixings. When we're talking about office receptions and places like that, we might be using stone that's 50mm thick on the walls and just mechanically fixed.
I'm afraid that is all we have
Okay.
time for, but it's been really fascinating. You can tell how much expertise is up on this stage right now. So Peter, Stephen and David, many thanks. At 2 o'clock we're going to be coming back. We're going to be looking at the future stars of the stone industry. Who could possibly replace those people we have up on stage right now? I mean, that is a real challenge. We've already been talking about it, but I'm going to look forward to meeting some of the young stars this afternoon. So I hope you'll come back for that, looking as well about how AI can affect the industry. So see you then. And they will be available for any further questions. Thank you.